All right, let's plot our graph. Remember, we have written out the coordinates here. We have chosen our scale, and then we have calculated for our divisions in case of anything. Okay, let's go. The first one, 2, 20. The 2 on the x-axis, 20 on the y-axis. The second, 4, 40. 4, 40. Third, 660. 6, 60. Then 8, 80. 8, 80. Then 10, 100. 10 all the way 100. Okay, so just simply join using our rule. I'm trying to align this. I have to feel the ruler hit the tip of the pencil as I engage the points. Make sure everything is aligned. Then I draw. We have our line graph or linear graph, to be specific, neatly drawn. Okay, and when we extend the line, it goes towards the origin. From this graph, we can see that for every 20 kilometers traveled, you have 2 liters of fuel used. Okay, so for every 20 kilometers, 20, where the points are, increase by what? 20, isn't it? The distance increases by 20 on the y-axis. So for every 20 kilometers that the car travels, okay, the fuel used is also 2 liters. So 20 kilometers traveled, 2 liters. Another 20 kilometers traveled, which is the 40, will yield another 2 liters, adding to these two and making 4. Another 20 kilometers traveled, that is a distance of 60, we can tell that 2 liters will be used again, right? So 2 plus 4, 6 liters. Another 20 kilometers traveled, 80 kilometers, will yield 8 liters on the x-axis. So we can also see that because the distance traveled is constantly proportional to the amount of liters used, because the amount of fuel used for every 20 kilometers that a car travels is constant, which is what? 2 liters. I'm taking it again. For every 20 kilometers that a car travels, the amount of fuel used is constant, which is what? 2 liters. Okay, so for every 20 kilometers, which is a constant, the corresponding fuel used is also 2 liters, which keeps getting constant as we move on. And so because they are constantly proportional, when we plot the graph, we are going to get a straight line, or we are going to get a linear graph. So even if we don't have the car's full data, like other additional distances covered by the car, because of this graph and the data that we have deduced from this graph, for instance, we can deduce that if the car were to travel a distance of, say, 160 kilometers, then it would have consumed a fuel of 18 liters based on the graph, because we know that it increases proportionally and constantly for every 20 kilometers, yielding 2 liters of fuel consumption. So let's go to this question. Okay, for this question right here, we are going to try to plot the values on this coordinate plane or on this grid, and then we'll plot it on our conventional graph sheet. We have here, says the table below shows the relation, relation between the time used and quantity of goods produced at a factory. So the relation between the time used to produce a certain amount of goods at a factory. Do you get me? So we have the time in minutes, then we have the quantity, that is the number of pieces of the said goods that are being produced. If you remember what I said earlier, that normally time is taken to be on the x plane, and then the quantity, the one which is this one, is taken to be on the y plane. Okay, so quickly we label our axis as I've already done, and then you can just look from the table without writing out the coordinates and just plot, right? Because this here, you know, it's 110, 560, and so on. So I can just start plotting right from the table without writing out my coordinate points. Okay, so 110, 110. Now look at this scale. I don't know the units of this full square. Okay, I don't know the value of this full square, but I can tell that it is 1 unit. Okay, for the x-axis it increases by 1 unit, so 1, the next 2, 3, 4, 5, 6, 7, 8, 9, 10. For the y-axis it increases by what? 30 units, so 30, 60, 90, 120, 150, and so on. All right, so if we want to plot something of this sort, okay, and it started from here, 1 between 0 and 30, okay, we can divide this space into 3, okay, so that each interval will be 10, isn't it? So we can just look at this and decide to put, like, let's say 10 here, then 20, then the rest 30, isn't it? Good. So 110 will be somewhere here, 1 on the x-axis, and then 10 somewhere here. So where they meet, let me put my 110 here. Okay, and then 560, 560. Okay, that is more obvious and easy to do. 670. So 670, I'll put 70 somewhere here. Okay, somewhere here. All right, so I hope you can follow through and do the rest. So we are going to get a line of a similar sort. Okay, right, so let's try and plot this on our conventional graph sheet. Okay, all right. So we have our axis labeled as at all times, very important. And then we have the names, the y-axis, what they represent. We have to write those as well if they are given. Okay, so quantity here, and then the time. All right, so first one on the plotting says 110, right? 1 on the x, 10 on the y. 1 on the x, granted. Why is 10? How can we deduce 10? This is where division comes into play. It's the reason why I went back to take you through divisions. Okay, good. So this is where divisions come into play. So for some questions, you do not necessarily need to waste time calculating for divisions if you know that the values can easily be spotted and plotted. Are you with me? No pun intended. All right, so if the values are easily plotted, then you don't need to waste time calculating for divisions. But when you are met with a situation like this, then calculating for the divisions becomes crucial. Okay, so let's calculate our divisions, right? We know that each interval, each 2 centimeter square interval has 10 divisions. That's a constant, right? So let's choose any 2 numbers. on the y-axis because we are focusing on the y-axis. As for the x-axis, I think it is given. But for the y-axis, we need to find 10 wherever it may be. So we are focusing on the y-axis, okay? So let's choose, sorry, I didn't write out my origin. So 0, good. So let's choose 30 and 60, okay? Let's choose 30 and 60. So between 30 and 60, the larger number is 60. So 60 minus the smaller number divided by what? The divisions, which are 10. And we are getting what? 30 over 10. Okay. And that will give us 3. So each tiny box is 3. Okay. It's 3 because we calculated the interval to be 3, right? And so when you count up 3 from 0, you have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, right? So we are on 30, isn't it? Good. So likewise, when we continue, 33, because the intervals are 3 as we calculated for. So 33, 36, 39, 42, 45, and so on, right? 63, 66, and so on. 93, 96, 123, 126, 153, 156, 183, 186, and so on. Good. So let's locate 10. We are plotting 110, isn't it? Even with that, we say 3, 6, 9. 9 will be here. The next number is 12, right? So we can see that 10 will be somewhere here, isn't it? So you approximately, let's put our 10 here, somewhere here. Very good. Can you all see that? Good. So our 10, 110. Then we go on 560. 5, 5, 60. Okay. So we plot it here. You can continue with the rest. So I have my plotted points here. So for instance, for 900, okay, 9 on the x-axis, 100 on the y-axis. We have only 90 on the y-axis, okay, 90. And after 90, we just go to 120. So we have to count the intervals. And remember, the interval is 3, isn't it? So 93, 96, 99. So 100 will be somewhere up a little bit. You can just gauge and put it somewhere in the middle here, just like I did. Very good. Now you are going to join the points with a straight line. Good. So after plotting the points on the conventional graph sheet and drawing a line through it, I realized that the initial 110 for the first, set of values, the initial 110 was an anomaly, okay? Was an anomaly because the line was not passing through it. So for those of you who are following with their own graph sheet and pencil, you realize that for the 110, the plotted point 110, the straight line does not pass through. So that point or that coordinate is an anomaly. All right. So I changed it. Okay. For the value on the y-axis should be something like 19. Okay. So I changed it to 19. And then the rest of the points just followed along a straight path or a straight line. All right. So thank you for participating in this class. For our next class, we are going to venture into the gradients of a line what it is and how to calculate for it. Okay, so stay tuned for more videos. Thank you. Bye bye.